So, or maybe it's just too early. And that's one too. All this paper. You're rich with paper now. Okay. Let's see here. Well, and the assignment. There's some stuff, so test one, because we've covered a lot of ground, right? But a lot of it has been kind of terminology and, you know, what's a variable, what different kinds of variables do we have? So all that is going to get tested in multiple choice. Okay, so there's going to be quite a few multiple choice, and then there's going to be just a few long answers, which you've got some practice for as well. Just before we start, for assignment 3, okay, on the back here, I did write a little note, but if for some reason I couldn't get my, because I've programmed this little normal distribution here, and I just couldn't get it to display 3 decimal places, even though I entered 3 decimal places, it only shows 2. And so you should just have Z equal to -3.291. So I put the actual numbers there. Okay. And they're just the exact same that are on your T table or your table C, right? So I just want to know what are all of the areas in the tails for all those lines. Okay. So should be easy 2 marks. Okay. So review day. Okay, here we go. And sorry, I did post this stuff, but it was very late last night, so I apologize. Things got out of hand. Was it busy Tuesday night? It's been a busy Monday morning to Wednesday morning, but here we are. Okay, so so I'll put it in the center here. Practice test number 1. Yeah. So everyone has a copy. I think I caught everyone. If you don't, let me know. I printed 10 less than I usually do, and I still have a chunk, so not sure what's going on there. So part 1 there, okay, so there will be 10 multiple choice questions from chapter 1. So these are just kind of theory questions. The only thing that's applied would be the 5-number summary and the 1.5 IQR rule to see if there's any outliers. Okay. But that's also going to be tested in a multiple choice scenario. Right? Oh. And there, and no worries, and okay. So going way back to the beginning, right? I've got variables on there. So I'll give you a summary. So from R, we've seen the summary command, the summary of a data set, right? So you'll see all the variables and the 5-number summaries, right? And I've also given you a summary in words of the variables, right? And so from there, you should be able to identify whether something's a categorical variable or a numerical variable. And then I'll also give you a research question, right? And from that question, you should be able to identify the response and the explanatory variables, right? And so that's what I expect for the variables point. Okay, the data collection. What did we arrive at for data collection? We just said, whatever you do, make sure that you have a random sample, right? At its core, your sampling has to be random. And we talked about different ways that we can do that, right? A simple random sample. We talked about clustered sampling, just briefly, multi-stage sampling, that kind of stuff, right? So that's what I mean with data collection. Visualization, right? That's going to depend on if you have a categorical variable or a numerical variable, right? If you have a categorical variable, we use bar graphs, right? So I'll say something like, for example, you've all seen the present data, right, in the lab. And so how would you visualize the boys variable, for example, right? The boys is the number of boys born each year. So that's a numerical variable. So we should use a histogram, right? So for categorical data, we use bar graphs. Right? And this is all on your sheet, so that's why I'm not writing it down. And for numerical data, you're going to use a histogram, right? And so those are your two options. And then I have describing the center and spread of distributions, right? And so if I give you a histogram and it looks approximately normal, right, then we're okay to use the mean and the standard deviation for the center and spread, right? But if it looks clearly skewed, right, where you have kind of a bulb and then a long tail, right, then you have to use the median and the interquartile range as your center and spread. Okay? So then we've got the 5-number summary, right? We're going to do a practice one in a bit here. Right, so I've got the multiple choice practice. So even though it'll be laid out like a multiple choice question, right, we'll do some practice. Okay? And then same thing for the 1.5 IQR rule to identify if there's any outliers. Okay? Any questions about that first chunk of questions? Okay. So then we move on to, there's going to be 15 multiple choice questions from chapter 2. So we're going to talk about things like, what does it mean for it to be disjoint? Right? And we've got practice for these, so I'm just going to run through them. Right, the definition of disjoint is two things are disjoint if they have no outcomes in common. Right? The sample space, that's a list of all possible outcomes. Right? Given a probability distribution, determine if it's valid. Right? So a valid probability distribution, we have to make sure that each of the outcomes are disjoint, right? There can't be any overlap in our outcomes. The probabilities all have to be between 0 and 1, right? That's on your formula sheet. Right? All probabilities have to be between 0 and 1. And the total probabilities, right? The sum of the probabilities of S, right? The sample space has to equal 1. Okay. And then we're going to use the general addition rule. So that's the probability of A or B is the probability of A plus the probability of B minus the probability of A and B, right, which we used before. The complement, right, that's just the opposite, right, of an event. Conditional probabilities, not so much, maybe one question. I think I threw one on the practice, so it's fair game. And then independence, right, we check independence by using this formula, right? We know that if A and B are independent, then we can show that the probability of A and B is the same as the probability of A times the probability of B. If that's not true, then they're not independent. Okay. And then, any questions about those? Like I said, we'll do a practice run through. Okay. Then there's going to be a long answer question with a tree diagram, right? So I've got like assignment 2, okay. And then a long answer question using the normal distribution like assignment 3. Okay. All right. let's get to work, shall we? So the multiple choice practice. I'll steal it from here. You've got it in front of you. Okay. So El Nino, the periodic warming of the Pacific Ocean, appears to affect the monsoon rains in India. Here are the monsoon rains in millimeters for the 10 strong El Nino years between 1871 and 2004. All right, so we've got a list of data, and I came out weird in this table here, but right, we've seen it as a list, but I can give it to you anyway. 10 data points, right? And then, so the first thing I ask is construct a 5-number summary of the data, right? So, all right, let's do that. For the 5-number summary, right? First thing we have to do is we have to sort this data from smallest to largest, right? That's going to be important. Otherwise, everything we do is, well, wrong. So, I think 604 is the smallest. Okay. And then 628. Keep me honest here, guys. How about, I guess I should use a different. 651. 669. 710. So you want to kind of check mark the ones off that you've used, right? 710, 740. Should have Martha Stewarted this. Had it ready. 781, 784, 790, and I ran out of room a little bit, 811. Pretty typical. Starts all lofty and then gets crammed. That's okay. Okay, so just double check that you have 10 data points, right? Because we need to have 10 data points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Phew. Okay. Because if you miss one, again, you're going to be all wrong. Okay. So remember the boop, boop, boop method. Right? There's fancy formulas that you could use, but I like the boop, boop, boop method. So just start from the outsides and boop your way in. So boop, 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 boop. I land on 710 and 740. Okay. Okay. So the median, right, to show that we're taking the average of these two, we circle the two middle ones that we landed on and then put a line through, right, to show that the median is actually at the line. So median is 710 plus 740 divided by 2. I've said it once, I'll say it again. Don't be a hero here. Use your calculator. So I get 725. Nice. So now we have to find our first quartile and our third quartile, right? And so we do the exact same thing. So the median is actually at the line. So the difference between when we've taken the average and actually used the number, if we've used the number as the median, we can't use it to find our quartiles, right? It's been used up already. So that's when we move one to the side, but now we just move one to the side of the line so we can start at 710 to find our first quartile. Right? And you saw that on assignment 1. So 710 and 604, booping in, boop, boop, boop. So Q1 is 651. So then, same thing for Q3, I'll start at 740, right? Because it wasn't used as the median. So 740 and 811, boop, boop. I get Q3 is 784. And then from here, right, because I've sorted my data, I can just see my minimum and my maximum. So then my 5-number summary starting with the minimum, Q1, median, Q3, and the maximum. The minimum is 604, Q1 was 651, median was 725, Q3 was 784, and the maximum was 811. Nice. On the test, right, this is going to be multiple choice. So then it would just say one of the options would be, for example, Q1 equals 651, right? So it would have a bunch of options for Q1, for example, and then you would just pick the right one. So technically you don't have to show the entire 5-number summary, right? But you have to be able to produce it to answer the questions. Okay. Any questions about that one?
If we have to do like one of these, like as an example, like a midterm, would we have to like do that 5-number summary in that specific order, or does it not really matter?
Yeah, a 5-number summary has to be either increasing or decreasing. So it has to be in, I like to go from minimum to maximum, but we have to go through one way or the other, right? So you can start at the maximum and work your way down, but I just like to see it from minimum to maximum, and that's just me. But it has to be in this order or reverse. Yeah. Okay, so part B asks, are there any outliers? Okay. So this little kind of unassuming question. Are there any outliers? Use the 1.5 IQR rule, right, to find out. Okay. So first thing we need to do is we need to find the interquartile range. Right? So the interquartile range, that's on your formula sheet, and it's just Q3 minus Q1. So the interquartile range here is 784 minus 651. We get 133. Okay. While we're at it, we can calculate the 1.5 times IQR. This is a separate calculation, right? So we want to be careful. So 1.5 times 133, 199.5. So the 1.5 IQR rule says that if we move down 1.5 IQR from Q1, right? So move down from Q1, then we've got a lower bound. Anything beyond that is going to be considered an outlier on the lower end, right? And then for the upper end, we do the same thing, but we have to add 1.5 times the interquartile range to Q3, right? So we tack it on to Q3 and extend it 1.5 times the interquartile range to get an upper bound. Okay. So this part is not on your formula sheet. So the lower bound, that's Q1 minus 1.5 times the interquartile range. Okay. And the reason I don't put it on your formula sheet is because this is conceptual, right? So thinking about, okay, I give you the interquartile range, and then you have to know to say, okay, 1.5 times the interquartile range down from Q1, right? So Q1 minus 1.5 times the interquartile range, that's your lower bound. And then up from Q1 or up from Q3, that's your upper bound. Okay. So because we've calculated 1.5 times the interquartile range, we can just plug that in right away. So Q1 is 651 minus 199.5. I get 451.5. So what do we do on the lower end? So now anything less than 451.5 up here, just draw a little line. 451.5, everything is larger than that, right? So there's no values smaller than 451.5. So there are no outliers on the lower end. Right? You can also just look at the minimum. So even if you don't have the actual data, you can look at the minimum and say, well, the minimum is 604. So the smallest value in the data set is 604. So there's nothing beyond 451. Right? So
what does the 199.5 demonstrate?
That's your 1.5 times the interquartile range. And that's just kind of a predetermined length that's been decided on to say, okay, anything beyond that from the quartiles, the first and the third quartile, that's going to be considered an outlier. So that's why it's called the 1.5 IQR rule. So since the minimum is 604, it is larger than the lower bound of 451.5. So there are no outliers on the lower end. Let's do the upper bound. The upper bound, right, now we go from Q3 and we add 1.5 times the interquartile range. So Q3 plus 1.5 times the interquartile range. Q3 is 784. 784 plus 199.5. 784 plus 199.5. 983.5. So same thing, any values larger than 983.5 is going to be considered an outlier. So if we go back to our sorted data here, 983.5 is also larger than the maximum, right? So you could look at your sorted data or just look at your maximum in your list, it doesn't matter. Okay. So again, since the max is 811, okay, it is smaller than the upper bound, of 983.5. So there are no outliers on the upper end. So there are no outliers. Womp womp. There's usually no outliers. But we have to test it either way. Okay. So, any questions about that one? No? All right. Let's get to the next question then. I'll steal all of this here. Oops. Okay. So here, I kind of decided to do the table a little bit last minute, because I think it might make answering some of these questions easier. Okay. So we've seen this table before. You didn't use it on assignment 2, but I mean, we could have. Okay. So this question is a probability question. Okay. The American Community Survey is an ongoing survey. So I steal most of my questions from old American textbooks, as you'll see for assignment 3. I think it was really funny. I like those, where there's little characters for each question. Back to the question. So an ongoing survey that provides data every year to give communities the current information they need to plan investments and services. Little plug for their survey that they do. The 2010 American Community Survey estimates that 14.6% of Americans live below the poverty line. Okay, so that's kind of a first fact. So there's an established poverty line, right? If you make below some certain income, you live below the poverty line. Okay, and so if 14.6% of Americans live below the poverty line, the probability of an American living below the poverty line is 0.416 or 0.46, sorry. Let me just speak. 0.146, 14.6%. You know what I mean, okay? So, then it goes on to say that 20.7% speak a language other than English, so a foreign language at home, and 4.2% fall into both categories. Okay. So if you're given percentages, right, we're first going to convert them to decimals, and then do our math with those decimals. Okay. So the first thing I got you to do is I've taken those probabilities that we've been given, and I've entered them into this table. Right? And so first thing I want you to do is fill in the missing probabilities. Okay? So there's some things that we have to keep in mind, right? Is that the total, the grand total here, so the sum of this one plus this one has to be 1, right? And the total of this one plus this one has to be 1, right? So we can use that to figure out what these probabilities are. Right? Those marginal probabilities. Okay. And then this one plus this one has to equal this one. Right? And this one plus this one has to equal this one. Right? So we have all the information that we need to fill in this entire table. Right? And just remembering that the total overall has to be 1. Okay. So I'll just work my way across. Okay. So the total on the below the poverty line, right? Doesn't matter what language you speak at home, is 0.146. So 0.146 minus 0.042, right? Taking away that overlap, that means that we have 0.104 living below the poverty line who speak English at home. Okay. Okay. So now let's figure out the probability that they live above the poverty line and speak a foreign language at home. Okay. So that's going to be the 0.207 minus 0.042. 0.165. I don't see enough to find the next probability, but I can find the overall probability of speaking English at home. 0.207 minus 0.042, because these two have to add up to this total, right? And so I'm going to use that same idea by saying that this one plus this one has to equal 1, right? So to find this one, I can do 1 minus 0.207. So 1 minus 0.207, oops, keep doing 204. 1 minus 0.207, 0.793. Now I can use that probability to find the next probability. So the probability of being above the poverty line and speaking English at home. So that's going to be 0.793 minus 0.104, right? Those who are below the poverty line but speak English at home. 0.689. And now we have two ways of finding this probability. Right? We can say, well, it has to be 1 minus 0.146, or it has to be the total of 0.165 plus 0.689. Right? So we'll just check it. I have 0.689 on my calculator, so I'm just going to add 0.165 to get 0.854. And then I'll just double check that when I add 0.146, it's 1. Phew. I'll give you this table probably. If anything, it'll be a blurb like this, but then I'll fill in just like you got it initially, right? Where I've given you these probabilities. People like it when I stick close to the practice test, so it'll be like this, right? Where you have to fill in the blanks and just kind of go from there, right? But I do expect you to be able to fill in the table, right? But I'll fill in the first 3. And if you have a look at, well, assignment 2, I don't have them marked yet. I know. Get a grip, Emily. I know. I'll have them marked this afternoon. So if you want to stop by anytime tomorrow, or I can bring them to the labs on Friday. You can grab them. Or I'll post the solutions. You can check out the solutions. Okay. So we could have rewritten the assignment 2 question like this too as a table. We just didn't. Okay. So now, any questions about that? Filling in the table? You'll see the benefits in a bit here. Okay. So part B, are living below the poverty line and speaking a foreign language at home disjoint. Okay. First, I'm going to define some shorthand notation, right? I'm going to say, okay, well, let P be living below the poverty line. And F be speaking a foreign language at home. Speaking a foreign language at home. So now we want to know our P and F disjoint, right? So our P and F disjoint. To be disjoint, they can never happen at the same time, right? And so if we look at our table here, right, living below the poverty line and speaking a foreign language at home, the probability of that happening at the same time is 0.042, right? So since the probability of P and F is 0.042 is not equal to 0, we know P and F are not disjoint, right? If they were disjoint, the probability would be 0. Questions about that one? Part C, what proportion of Americans live below the poverty line or speak a foreign language at home? So this is like the assignment. Probability of below the poverty line or speak a foreign language at home. So P or F, right, just like the assignment. You don't have to use the formula. You could use the table, and I'll show you how in a sec. But that's the probability of P plus the probability of F minus the probability of P and F. The probability of P, right, we were told was 0.146, right? It's the total probability of living below the poverty line. 0.146 plus the probability of F was 0.207 minus the probability of A or P and F is 0.042. So we have 0.146 plus 0.207 minus 0.042, 0.311. If you really don't like using the formulas, right, the formulas are there just to make things easier, right? If you don't like using them, then you can talk your way through what you're doing here, right? You could say, okay, since I know that the probability of living below the poverty line is 0.146, and I know the probability of speaking a foreign language at home is 0.207, right? I can add those up, but then I have to subtract the overlap of 0.042. You can say that. You're saying the formula, but right? Just different ways of getting there. Okay. So you'd get the same answer as long as your reasoning was correct. Okay. So, part D, what proportion of Americans live above the poverty line, right? So we have to be in the above the poverty line section and speak English at home. So this is where it's nice to have this table, right? Because then we can just say, okay, so above the poverty line, this is where we have to be, and we can't speak a foreign language at home, but we do have to speak an English at home, right? So then the probability that we're looking for is just 0.689. So because we've got the table, we can just say 0.689 and move on. That's nice. Okay. So in probability notation, you would say the probability of not P and not F is 0.689 from table. Nice. Right? Because trying to figure that out with formulas, that would be kind of bothersome. Okay?
I just think 6.689 falls under English at home and above poverty line, so why?
Because I want to talk in terms of just P and F, right? And so below the poverty line, that's P, but above the poverty line, that's the complement of P. And then foreign language at home, I'm calling F, so English at home must be not F, the complement of F. Right, and so here we want to know what proportion of Americans live above the poverty line, right, so not P, and speak English at home, so not F. Does that make sense? Okay. Any other questions about that one? It's tricky, but because we have the table, it's kind of not as much work as it could be. Okay. So, E. What proportion of Americans live below the poverty line, given that they speak a foreign language at home? So, if we know that they have to speak a foreign language at home, I'll just scroll down here, if I can reach. So they have to speak a foreign language at home. Right? So the total, right, is going to be this 0.207. Because that's given to us. So we know, okay, now narrow it down to look at those who only speak a foreign language at home. Okay? And then now we want to know of those 20.7%, right, how many live below the poverty line. So now, how many of these guys live below the poverty line? So then we could say, okay, well, that's 0.042 divided by 0.207. So, for E, we're asked to find the probability of living below the poverty line, given that they speak a foreign language at home. Okay. Which is going to be 0.042 divided by 0.207 if you're just looking at the table. So from the table, right? Or if you want to use the formulas, or from formulas, oh, given. Okay. Or from formulas, we know that the probability of P given F is the probability of P and F divided by the probability of F. That's right. Exactly. Yeah. Yeah. Because the 0.042 is just in the total population, those who live below the poverty line and speak a foreign language at home, right? But now we're saying, okay, not out of the total population, just out of those who speak a foreign language at home, right? So we're just kind of narrowing down the population a little bit, right? So that's the difference. But now that we have this formula, right? If we look, well, the probability of P and F, that's the 0.042. And the overall probability of F, right, is 0.207. So you get to the same place, right? Use whichever way makes more sense to you, right? Just looking at the table and saying, okay, probability. So I have to speak a foreign language at home. So that narrows me down to the 0.207, right? And so now 0.042 as a percentage of 0.207. Right? So 0.042 divided by 0.207. So that probability is 0.202898551. Roughly 0.203. I would love to see all those decimal places before you round. Or even just half of them before you round. Okay. But I guess this will be multiple choice, so. Okay. All right. Any questions about that one? Right. So 2 ways of getting to the exact same thing, right? Use whichever way comes naturally to you, because that's the way it'll stick. Okay. So is the event that someone lives below the poverty line independent of the event that the person speaks a foreign language at home, right? So now we want to check, okay, so this is part F, yeah. So we want to know, are P and F independent? So we're going to check the probability of P and F. Does it equal the probability of P times the probability of F? So the probability of P and F we know is 0.042. The probability of P, right, that's the general probability of living below the poverty line. So that's going to be your 0.146. And the probability of F, the general probability of just speaking a foreign language at home, regardless of how much money you make, is 0.207. 0.146 times 0.207 is 0.030222, which is not equal to 0.042, right? Meaning they're not independent. Okay. So since the probability of P and F does not equal the probability of P times the probability of F, we know P and F are not independent. Okay. Any questions? Great. So let's do some long answer practice. Steal this here. Okay. So I just want to say, and I have put it in here even, right, that this one is a little bit more complicated than what I'm expecting to see on the test, right? But I just want to show you something big, and then the test will seem easy, hopefully. Right. So lactose intolerance causes difficulty. I think we all know what it is. Digesting dairy products that contain lactose, milk sugar. So it's particularly common among people of African and Asian ancestry. In the United States, ignoring other groups and people who consider themselves to belong to more than one race, right? So just narrowing it down to 3 races. Okay. 82% of the population is white, 14% is black, and 4% is Asian. Moreover, 15% of whites and 70% of blacks and 90% of Asians are lactose intolerant. So, so this very risque textbook questions that I've stolen. So, first thing we're going to do, right, is build a tree diagram to figure out all these probabilities. Like I said, this one is a little bit more complicated than what I expect of you, right? But you were all freaking out because the assignment one boiled down to something too easy. So I can't win with you guys. Okay, so let's do our tree diagram. So this is a long answer, right? So you have to show your work and everything. Build a tree diagram labeling all the appropriate probabilities, including the probabilities at the end of each branch. So I'll show you what I mean, right? But that's going to be when you multiply through to get all those probabilities. Okay. All right. So first thing we have, right, our first layer is our quote unquote race layer. We want to give ourselves lots of room here. Right, because we've got 3 categories for race. Okay. So we're going to start with we'll say white. The probability of going into the US and pulling out a randomly selected white person is 0.82. Okay. Then pulling out a black person, 0.14, pulling out an Asian person, 0.04. We can double check, right, that if we add these probabilities all up, the total should be 1, right? Because all our branches look at all the possibilities. Okay. I mean, not technically, but for this example, it does. Okay. So now we build our lactose layer, let's say, right? So if you're white, you're either lactose intolerant, right, with a probability of 0.15, right? Or you're not lactose intolerant with a probability of 1 minus 0.15, right, or 0.85. So we'll say, okay, here, each of these branches, just to make sure we have enough room, right, we can put our 2 branches, our lactose intolerant branch and our non-lactose intolerant branch, off of each of these. So I'm going to make my left-hand branch the lactose intolerant and my right-hand branch not lactose intolerant for all of these. So L, not L, L, not L. Okay. What's extra hard about these, right, is that the probability of L is not the same for each of these branches, right? It changes depending on which branch we're at. So the probability of L for whites is 0.15. The probability of L for blacks is 0.70 and 0.90 for Asians. So the total across these branches has to be 1. Right? And so this here must be, the probability must be 1 minus 0.15, which is 0.85. Trying to write really tiny here. One minus 0.70, 0.30. These ones we could probably see. 1 minus 0.90, 0.10. So what we didn't do before, but I found a video that I really liked, and so I'm going to start doing it too. At the end of each of these branches, right, I'm going to list the outcomes, right? So what happened at the end of each branch? So first we have WL, right? So here we had first, we picked a white person, and then we found out they were lactose intolerant, right? So just listing all these outcomes at the bottom of each branch, W and not L. Right. BL, B not L, AL, and A not L. Okay. So now I can calculate the probabilities of each of these things, right? So this is what I mean by including the probabilities at the end of each branch, because I want you to go through and I want you to calculate the probabilities of WL, W not L, right? How do we do that? We need to multiply down each branch, right? So the probability of WL is going to be 0.82 times 0.15. 0.82 times 0.15. 0.123. Oops. Then we can go to, need a little bit more room here. The probability of W and not L is 0.82 times 0.85. 0.82 times 0.85. 0.697. Probability of BL is 0.14 times 0.70. Right, I'm just multiplying down these branches. 0.14 times 0.7, 0.098. Probability of B not L is 0.14 times 0.30. 0.042. Probability of AL is 0.04 times 0.9. Oops. 0.04 times 0.9. 0.036. The probability of A not L is 0.04 times 0.10. 0.004. Whoa. like I said, on the test, each layer is only going to have 2 branches, right? So we'd only have 2 branches, so this all would not be there, right? So a little bit easier to deal with. It says on the front, well, not the total, but 10 plus 15 plus 8 plus 8. Whatever that is. Okay. So this is going to be the majority of your marks for this question, right? Because this is all the work. Okay. And so now, right? So that's part A. And now we're ready to move on to part B. Okay. What % of the entire population is lactose intolerant? Okay. So now we want to go through and we want to figure out, okay, well, these guys are lactose intolerant, these guys are lactose intolerant, and these guys are lactose intolerant, right? Because these percentages that we calculated are out of the total population, right? And so, right, we want to figure out which ones have an L in there, because those are the lactose intolerant people, and then we can just add them up, right? So for part A, we can just say, okay, well, we want to get these guys, and these guys, right? They're all lactose intolerant. So to answer the question then, you could just say that the probability of WL plus the probability of BL plus the probability of AL is, and we've done the work, so now we can just say it is 0.123 plus 0.098 plus 0.036. So we have 0.123 plus 0.098 plus 0.036, 0.257. So then 25.7% of the entire population is lactose intolerant. Nice. C. You can write a blurb, but it won't be worth marks, so nah, I know you won't. So, what % of people who are lactose intolerant are Asian? Okay, so same as before that we just did, right? So now we're saying, okay, of these people, right, of the 0.257, okay, how many of those are in the AL group, right? Asian and lactose intolerant. So we know the probability of AL is 0.036 divided by 0.257, or 257, sorry. Don't know where the 8 came from. Oh, we could say here, if we wanted to, so the probability of just lactose intolerance in general is 0.257. Okay. Now we want to know, right, what % of people who are lactose intolerant, right? So given that they're lactose intolerant, what percentage are Asian? So the probability of being Asian given that you're lactose intolerant. That's the probability of A and L, right? Or just the probability of AL as we've written it, divided by the probability of L. So it's going to be 0.036 divided by 0.257. Right. Same thing though. if you just want to talk your way through it, right, and not use the formulas, that's fine too, right? And say something like, okay, now I have to narrow it down to the population that is lactose intolerant, right? And I know that probability is 0.257, and of those, 0.036 are Asian, so I have to do 0.036 divided by 0.257. Right? So you can talk your way through it. Doesn't matter how you get there. Right? You'll use the same values. Any questions about that one? Okay. So let's see here. Our last long answer practice. If you're like me, you're thinking, oh, finally, no more probability questions. Probability is so tricky. So manatees. Manatees travel at a speed that's approximately normally distributed with a mean of 3.8 miles per hour and a standard deviation of 1.34 miles per hour. Okay. So we're going to use this information to find probabilities, but not in the way that I think of probabilities. I think of probability as chapter 2 stuff. Okay. Here we're finding probabilities, but the fun way. Okay. So first thing we're going to do, right, before we even attempt any of these questions, I would draw out the normal distribution just in general, right? So we're given that, okay, the speeds of the manatees follow a normal distribution with a mean of 3.8 and a standard deviation of 1.34. Okay. So here we've got our speeds. So part A, what proportion, and I want you to remember that proportion is the same as probability, which is essentially the same as a percentage. Right? Remember, I blew your mind with all these P's they mean the same thing. Proportion, probability, percentage, right? A percentage is a proportion times 100. Right? So that's why I have squiggly equals, but essentially they're all the same thing. Right? So what proportion of manatees travel faster than 4.7 miles per hour? Okay, so let's draw out our normal distribution. Centered on 3.8 and sigma is still 1.34. And we want to know how many of them are faster than 4.7. So 4.7 is somewhere above 3.8. And I want to know what's this area here above it. And you do have to show this graph, right, for each of the questions. And just to show me that you understand what the question's asking, right? Okay, so now what? Now we have to standardize 4.7, right? Convert it to a z-score, right? So we have a raw score, x of 4.7. We want to convert it to a z to find the probability, right? So z is x minus mu over sigma. So we have 4.7 minus 3.8 over 1.34. 4.7 minus 3.8 is, I'll show one step. You don't have to show this step, 1.34. Divided by 1.34. 0.6716 41791. need at least 3 decimal places, right? I'll have to take marks off if you round too much. Right, so we need at least 3 decimal places. Why? Because we're about to use the table, right? The table gives us 3 decimal places, so we have to use at least 3 decimal places. Right? So we're going to use Z is 0.672. Or if you want to use more decimal places, that's fine too. So now what? Now we go and we take our calculated value, okay, and using table C, we find the absolute value of Z equal to 0.672. Right, in case there's a negative, we drop it using the absolute value, right? So I just take my Z that I calculated, I put it in the center of my page, right? I tell the marker, I tell myself what I'm doing exactly, right? You just want to articulate everything that you're doing. So using table C, we find that our calculated Z, right? And we try to go on here and we try to fit it between 2 values, but we can't. It's just less than 0.674. Okay. And all we know is that it's bigger than 0, right? So that's what's going on there. Right. So now we go on to find our one-sided P, right? Our one-sided P gives us the area and the tail, right? So the one-sided P is between 2 values. Has to be larger than 0.25, right? Because if we scroll down from 0.674, we get a one-sided P of 0.25. So it has to be larger than 0.25, but if we have a Z of 0, Z of 0 is at the mean, right? At the mean, the area in the tail, in the upper tail, is 0.5, right? The mean splits the distribution in half, right? So then we can say, okay, well then it has to be between 0.25 and 0.50. And I'm gonna draw this one's optional. Yeah, I'll do it in this, we'll try this drawing to show. Okay, so here we are on Z. Z is centered on 0, right? And we went to the graph, and this is what you're doing on the on assignment 3, right? The last question. Okay. So I've given you some Z values, and you're gonna say, okay, if I have a Z of 0.674, the area in the tail,
672.
oh, but from the table,
Okay.
right? We have 0.674. It doesn't help that they're so close, right? But 0.674, that's from the table, and we know that this area is 0.25 because this is our one-sided P. Okay. And our value is 0.672. So all we know is that the area in the tail is somewhere between 0.25 and 0.50. Therefore, the probability / proportion of manatees, sorry, question said proportion of manatees that travel faster than than 4.7 miles per hour is between 0.25 and 0.50. I'll just crank out part B. What's the probability of a manatee that travels slower than 1 mile per hour? I'm going to leave that one because that's the exact same as part A, right? Just slower than 1 mile per hour. We'll do part C. I'll fill it in before I post the notes. Okay. But part C, how slow do the slowest 15% of manatees travel? So here we draw our graph, 3.8, sigma is 1.34. And at some point here, this area is fixed to be 0.15. So then you're going to use, using table C, we find the Z star corresponding to a one-sided P of 0.15 on the lower end is Z star equals, so we find 0.15 is negative 1.036. Negative, right, because we're in the lower end. So now we have Z equals X minus mu over sigma, or if you want to use that formula for X that's on your formula sheet, you can, right? But now we use Z is negative 1.036 is X minus mu, which is 3.8 over 1.34. 1.036 negative times 1.34, negative 1.38824 is X minus 3.8. Add 3.8 to both sides. I get X is 2.41176. So then the slowest 15% of manatees travel at speeds of up to 2.41176 miles per hour. And then try part D on your own. I'll just pause the recording. I'll record it and post it with the notes. Okay, I think I'm back. I want to share my screen here. Looks like I am. Looks promising. Okay. So I'll just go to B here and just kind of cut this down. Oops. How am I going to do that? There's so much here. I'll just say C after C. Okay. So we're back here and we figured out that X must be 2.41176. So that means that any manatees that are slower, right, than 2.41176 miles per hour, they're in the slowest 15%. So therefore, the slowest 15% of manatees travel at speeds less than 2.412, let's say, rounding, miles per hour. So let's go back to B. B is essentially the same as part A, right? Because we have, what's the probability that a manatee is slower than 1 mile per hour? So we're still centered on 3.8 sigma, still 1.34. And now we're here at 1 mile per hour. So we want to know what this area is. So same thing, right? We're going to find the Z score. So Z is X minus mu over sigma. X is 1, mu is 3.8 divided by sigma, which is 1.34. Where did I put my calculator? One minus 3.8, negative 2.8 divided by 1.34 divided by 1.34 is negative 2.089552239. Just giving you all the decimal places, right? But we only need 3 decimal places. So Z is negative 2.08. Oh, I should have rounded. No harm, no foul. I'll just do, need at least 3 decimal places. Nothing that says we can't have more. Okay. So now I'd write a note to my marker using table C, right, to say where I'm finding this stuff. And I put the absolute value of my Z in the middle, Z equal to negative 2.0896. Right. The absolute value takes away the negative, is between, and so 2.0896 is between 2.054 and 2.326. I just want to read through here and check to make sure, okay, 2.054, that is less than 2.0896, which is less than 2.326. So the one-sided P is going to be between, so tracing down from 2.054 and 2.326, reading from right to left, 0.01 to 0.02. So the area in the tail is somewhere between 0.01 and 0.02. Right, again, I'm just going to draw this optional little graph here. Because what we're saying, Z is centered on 0. Right? We have a Z of negative 2.0896, right? And so we're told that between negative 2.054 and negative 2.326, right? The area in the tail for negative 2.326 is 0.01. The area in the tail for negative 2.054 is 0.02. And we have our little guy somewhere in here, negative 2.0896. So now we can answer the question, right? Therefore, the probability of a manatee that travels slower than 1 mile per hour is between 0.01 and 0.02. Great. So now we can do part D here. What speeds capture the central 90% of manatee speeds? So here we've got our normal distribution again, centered on 3.8. Sigma is still 1.34. And at some point here and here, this area, we're forcing it to be 0.90. Okay. So we have a couple of ways that we can find this, right? But we want to find this value and this value. Okay. I'm going to use the table C. Using table C, okay, and the confidence levels, right, give us the central 50, 60, 70, 80, 90, etc. percent. With a confidence level of 90%, we know Z star must be plus minus, right? Plus minus because we want the lower end and the upper end. 90% corresponds to a Z star of 1.645. Right. So for the lower bound, use Z equal to negative 1.645. Okay. Hi. Good to see you. And then we say Z. Okay, we're back. Had some visitors. So now we can use Z. Am I still sharing my screen, I wonder? I'll just make sure. Yeah, it looks good. Hopefully it's still recording the screen. So Z is X minus mu over sigma. Using Z is negative 1.645 now. We want to solve for X when mu is 3.8 and sigma is 1.34. So we can multiply both sides by 1.34. So we have 1.645 negative times 1.34. Negative 2.2043 is X minus 3.8. Add 3.8 to both sides. We get X is 1.5957. Okay, we're back. So the lower end is going to have an X of 1.5957. So now the upper end. So for the upper bound, for for the upper bound, use z equal to positive 1.645. Right, just the positive value. So then again, we do the same thing. Now z is still x minus mu over sigma. So z, we use 1.645 is x, which we're solving for. And if you wanted to use your formula for x on your formula sheet, you're welcome to. Mu is 3.8 and sigma is still 1.34. So now we have 1.645 times 1.34 makes positive 2.2043 is x minus 3.8. Add 3.8 to both sides. We get x is 6.0043. So that's okay, home stretch here. So the central, so now we know the central 90% of manatees travel at speeds between the lower bound 1.5957, 1.5957, and 6.0043 miles per hour. Woohoo! And that is the end of our review. Great. Oop. And stop.